In this video, we're going to talk about direct variation. Suppose A and B are variables. We say that A varies directly as B, or A is directly proportional to B, if there is a positive constant K such that A is equal to KB. And K is called the constant of variation, or the variation constant. Now, a lot of times we use the letters Y and X instead of A and B, but not always, so I wanted to use A and B in the definition here. So let's do an example. Suppose y equals 5x. And notice that this has the form y equals kx. So this is direct variation. And the constant k is 5. And let's plug in some numbers for x and y here. If we plug in x equals 3, notice that y will be 15. Now, one of the things that's key to recognize about direct variation is that if, for example, we were to double the input, we would get double the output. So let's check, is that the case? If x equals 6, what will y be? Well, notice in our equation here, if x is 6, y will be 30. So we doubled our input and we got double our output. Or if we tripled our input, okay, if x equals 9, we should triple our output. Y will be 45. Or if we multiplied our input by 1/2, we took half of our input, so x equals 1.5 instead of 3, our output will be 7.5, right? Half of 15. Okay, so that's an important property of direct variation that you need to know. So let's look at an example. The formula for the circumference, c, of a circle is c equals 2 pi r, where r is the radius. Now notice that this is really saying that c varies directly as r, because c is equal to a constant times r. Namely 2 pi. The k will be 2 pi. So notice that c varies directly as r. What is the constant of variation? Well, we can write it out. The k will be 2 pi, which is approximately 6.28. So the circumference of a circle varies directly as the radius of the circle. Let's look at another example. Suppose y varies directly as x, and that y equals 42 when x is 7. Find the variation constant and an equation of variation, then find y when x is 21. So our equation is going to be y equals kx. Now we need to find the k though. So when y is 42, let's plug in 42 for y, x is 7. So what will the k be? Well, we have 42 equals 7k, so k is going to be 6. So 6 is our variation constant, and our equation of variation would be y equals kx, but the k we found was 6, so it's y equals 6x is our equation of variation. Now the question is, what is y? Find y when x is 21. Now we could do this by plugging it into the equation, and we will in a second here, but notice that they're asking us to use 21 for x when initially we had 7 for x. So we're tripling our input, so we should triple the output. We should triple the y, and 3 times 42 is 126. So I'm guessing our final answer should be 126. Well, let's check. Y equals 6x, but in this case we're using 21 for x, 6 times 21, and 6 times 21 is 126 as we had expected. Now, one misconception that students sometimes have is that to say that y varies directly as x simply means that when x goes up, y goes up. And that is true, but direct variation doesn't simply mean that. So let's look at an example. If we have y equals 3x, that would be direct variation. Now, we could actually graph this, y equals 3x. That's just a straight line that goes through the origin. Notice it has the form y equals mx plus b, where the b is just 0. And notice also that along this curve, if you look at the ordered pairs along this curve, the x's and y's, as x goes up, y goes up. That's certainly true. But notice that would also be true for something like this. On this curve, notice as x goes up, y goes up, right? As we go left to right, this is going up. But this is not direct variation because it doesn't have the form y equals kx. So even though as x goes up, y goes up, that does not give us direct variation. Even a linear equation is not necessarily going to be direct variation. So something like this, it has the form y equals mx plus b, but the b is not 0. So this is not direct variation.